record what? That's weird. All right. Anyway, so let's keep going now. So here what we have is we have a deck of 52 cards, okay? And what we're doing is we're choosing, okay, a card at random. We're noting what the card is, and then we're choosing a second card. So it's really kind of like from the marble example, right? You're choosing something, you're not putting it back though. So you could probably guess that the two events, then you choose a card, then choose a second card. You could probably guess that those two are not independent. I mean, right away you should be able to see that because for the second card, there's one less card in the entire deck. Not 52 cards anymore, it's 51. The first one that gets both hearts, right? Well, we're going to let A be the event, okay? That the first card we have is from the suit of hearts. We're going to let B be the event. The second card is from the suit of hearts also. So A is the event, the first card is from the suit of hearts. B is the event, the second card is from the suit of hearts, okay? Remember, there are 13 hearts in the deck, 13 cards per suit. And we want the probability of both events, A and B, occurring. That's what we're looking for. Okay, well, for A, there's 13 cards you could choose from, right? So the probability of that is 13 out of 52, as you can see. All right? Okay, that's good. Now, let's get the probability of B given A. I mean, we knew they were not independent, but even if we didn't know for sure, it probably would be a good idea to get the conditional probability anyway. Because we know A has occurred. So for the probability of B given that A has occurred, well, if A occurred, there's one less card in the deck, right? There's also one less card from the suit of hearts. So there's 12 hearts left, and there's 51 cards left altogether. So this probability is 12 out of 51. Okay? So that's what we get here. Okay, good, good. So altogether then, the probability of A and B occurring, right? The probability of that occurring would be 13 out of 52 times 12 out of 51, right? We're using that formula, the probability of A times the probability of B given A. That product turns out to be this, as you can see. Okay. All right. Good. That's what we get here. Okay. Now, I hope that makes sense. Okay, what about that both cards are aces? It's really the same idea, right? The only difference, though, is that there's not 13 aces, there's 4 aces. But the idea is the same. We're going to let A be the event. The first card is an ace, okay? We're going to let B be the event. The second card is an ace. So what do we want to do? We want the probability of both A, B occurring. That's what we're looking for. Okay, so again, there are 4 aces in the deck, right? 4 aces. So the probability of A is 4 out of 52. Excuse me. Now, what about the probability of B given A? Okay, well, again, we know A has occurred. We know there's one less ace in the deck. Hence, there's also one less card in the deck, deck. So the probability of B given A is 3 out of 51. Right? Again, there's one less card in the deck, right? And one less ace. And so because of that, the probability of A and B is this product of these two, excuse me, which is this. You get 12 over 4 over 52 times 3 over 51, the product, which is this, 12 over 2,652. That's fun. That's what we get there. Okay. Now I did this for the other class. Let me do it for you guys. For the ace of hearts, okay? I can see the chat now, so you can type if you want. Did anyone get that probability? That both cards are the ace of hearts? You could type in the chat if you got it. Okay, one person wrote 0 over 2,652, which is the same as 0. Okay, so one person said 0. Anyone else? I didn't say she was wrong. Anyone else? Guess we'll play hardball then. Huh? I mean, well, okay. Sorry. Do a poll. Make it fun. Okay, some people are saying yes. You can say no if you don't think it is. That's fine. Okay. I know it's not an easy problem. Don't worry. I'm not gonna, change your grade in any way. So don't do that. All right. Well, if you think it's 0, you're right. Well, let me stop the poll now. But yeah, the answer is 0. And how do we know that? Well, how many ace of hearts are there in the deck? Someone type that in chat. Oh, I gotta say it. So, yeah, so 2 people, no, 3, a bunch of people are saying 1. Okay, so if there's only one ace of hearts in the deck, is it possible to choose 2 of them if you're not putting a card back? That's possible, right? You're choosing a card at random, but you're not putting it back, though. So there's no way both cards can be the ace of hearts. I mean, if we did take the card out and then put it back before we drew the second, that's different. So the answer is 0. All right, that was fun. I thought so. All right. Let's see. Both cards are aces? No, it's not what I wanted to. That's not the slide. This is the slide. Here we go. So both cards are the ace of hearts. Right. It's 0 because there's only one. You can't draw that card twice since we're not putting the first card back. So, okay, so that's what happens there. What about 4? Although I guess the answer is there, so let's just go through it. So that they're both red aces. Well, if we let A be the event, if we let A be the event, the first card is a red ace, right? Keep in mind, red ace, the cards that are red, those are hearts. They're from the suit of hearts or diamonds. So suit of hearts, suit of diamonds, those are red cards. That's what they mean by a red ace. I'm sorry if I didn't make that clear first. Although I think I might have said that before. But anyway, so for the first card to be a red ace, A is that event. B is the event. The second card is a red ace. So there are 2 red aces in the deck, right? The probability of A is 2 out of 52. 2 out of 52. Well, assuming A occurred, right? We want the probability of B given A. Well, there's only one red ace left, right? There's only 2 red aces in the deck. Ace of hearts and ace of diamonds. So because of that, the probability of B given A is 1 out of 51. Altogether, the probability of A and B is better. That's what we get. So it's 2 out of 2,652. Wow. Okay. All right, let me just stop the recording.